Alright, this is the homework video for section 2.2. It's on page 109, and we're going to start with problem number 9. And if we have f of x equals negative 2x plus 3, we simply have to match that with the graph out of the choices. So the way I would do that is I would see which parent function this is similar to. So this is a linear function with a y-intercept of 3 and a slope of negative 2. But actually, the only line is choice F. So in number 17, let's take a look at the directions first of all. So it says to look at the parent function, which in this case is y equals x to the third. And then to describe the transformations, and do we have to graph it? Sketch the graph, yes. So our f of x in number 17 is x minus 2 cubed. So we would say that's going to go 2 to the right. So if the original parent is like this, then 2 to the right, we're just going to go 1, 2. And put our critical point in there, and then it's going to be the same graph. There's no stretch, compress, nothing like that. In number 19, we have f of x equals negative x cubed plus 1. So the transformations are this flip over x and up 1. So let me go down here and draw my graph. Here's the parent. So I'm going to go up 1. So I'm just going to make my critical point there, and then the flip, then we look like this. Number 21, in the same section, now we have f of x equals negative x minus 2 to the third. So once again, we have our negative is outside the parentheses, so that's a flip over x. And the minus 2 is 2 to the right. So if we draw our axes, and here's my original parent, and then I'm going to go 2 to the right, and then my flip is like this. Number 25, we have a new set of directions, so let me take a look at those. So use a graphing utility to graph the functions f and g in the same viewing window. Zoom out far enough to see the right hand and left hand behavior. Do the graphs of f and g have the same right hand and left hand behavior? Explain why or why not. So let me get my functions down here. F of x equals negative x to the fourth minus 4x cubed plus 16x, and then g is just negative x to the fourth. So my prediction is that they will have the same end behavior, and I'm going to pause and graph these on Desmos real quick. Alright, so I'm using the Desmos app on my phone, and I can see like the one in red is the more complicated function, and it has a few more lumps and humps in it, but they basically are downward opening, which is what I could have predicted, being that it has a negative leading coefficient and an even power. So they do have the same left and right end behavior. In number 27, I've got two functions, f of x, and these are cubics this time, negative 2x cubed plus 4x squared minus 1. G of x equals 2x cubed. So they're both cubics, but this one has a negative leading coefficient and this one has a positive leading coefficient. So the negative, I'm expecting this, and the positive, I'm expecting that. So I'm going to pause it while I graph it again. Okay, so perhaps you can see, let's see if I can dim my screen a little bit and it'll be easier to see on the computer. Alright, so the green one is my original function, and it's got rising to the left and dropping to the right. And then the orange one is the 2x cubed with the positive coefficient, and it's falling to the left and rising to the right. So my predictions were pretty good, as they usually are. Do they have the same end behavior? So to answer the question, no they don't. Why or why not? Because of the leading coefficient test. F of x is negative, and the leading coefficient of g of x is positive. Okay, in number 31, let's see, do we have a new set of directions? Yes. And it says applying the leading coefficient test, so let's look at, we're basically doing the same thing. So in number 31, we just have one function though. G of x equals 5 minus 7/2 x minus 3x squared. So if I put this in standard form, negative 3x squared minus 7/2 x plus 5, I can see my leading coefficient is negative. I have a second degree polynomial, so I'm predicting that will be the end behavior of the graph. And so then let me put that into Desmos real quick. And so that's negative 3x squared minus, and instead of 7/2, I'm going to put 3.5x plus 5. And I've got a downward opening parabola, just like I predicted. In number 39, we've got to find the zeros algebraically, graph the function, use the graph to approximate zeros, and compare. Okay, so 39, let me write down my function. G of t equals 1/2 t to the 4th minus 1/2. Okay, so now I'm going to use my factoring skills. And I see that I have a GCF, so I'm going to factor out 1/2. I get t to the 4th minus 1, and then I notice this is a difference of squares, so in order to factor that I can do t squared minus 1 and t squared plus 1. And then I see that I have another difference of squares, so t minus 1, t plus 1, and then t squared plus 1. I just kind of know that that one is going to give me some imaginary solutions, which we're studying in section 2.4, so I don't want to dwell on that too much. So you can just trust me, and we could say that the -1 and the +1 are the only real zeros. So then I want to graph this, and I'm going to put it into Desmos, and I'm going to do 0.5 times x to the 4th minus 0.5. And so after I graph that, you can see that it does cross at 1 and -1. Those are the only two places it crosses, but since it is an x to the 4th, we know it has 2 additional roots, and since they're not x-intercepts, they must be imaginary, just like I said. So let's go on to number 47. And in number 47, the directions say same directions. So let's go ahead and get it in the screen. So at number 47, we've got 4x cubed plus 4x squared. No, that's problem 46. Sorry, 4x cubed minus 20x squared plus 25x. So I'm not asking you to do anything with a cubic yet because the x factors out. So 4x squared minus 20x plus 25. And the key to factoring this is to notice that it follows the rules of a perfect square trinomial. I've got a perfect square here, the square root of that is 2x, a perfect square here, and the square root of that is 5. 2x times 5 is 10x, and double it and you get 20x. And because of this minus right here, I need to put that as a minus. So here's my factored form of my polynomial. And now I simply need to find the zeros. So since we start off with a power of 3, there's going to be 3. So my first 0 is 0. And then I'm going to have a multiplicity of 2 here because I've got a square factor. So what value of x makes this whole expression equal to 0? Well, if you're not good at that, you can bring it out to the side and make yourself a little equation. So 2x equals 5, so divide by 2, x equals 5 halves. So those are the zeros, and then this one just has a multiplicity of 2. And when we graph it, we'll be able to see that this should be a place where we have an inflection point right on the axis. So let's type it in. We have 4x cubed minus 20x squared plus 25x. And lo and behold, let's see, can you guys see this? Lo and behold, we have a crossing at 0 and an inflection point right at 2.5, just like we predicted. So number 59, it looks like we have a new set of directions. So I want to use a graphing utility to graph the function and approximate any real zeros and relative extrema. So I don't know if that's a vocab word we've talked about yet. So let's take a look at what happens when we graph it, and then we'll talk. So I'm just going to plug it in. Get rid of that other one. So 2x to the 4th minus 6x squared plus 1. It's kind of interesting to see what happens to the graph also as you type the different pieces of the equation in. So normally to the 4th I would expect it to be both opening. So this tells me I should change my window just so I can verify that. It's an even function, positive leading coefficient, both sides open up, but this one crosses in 1, 2, 3, 4 places. So I've got 4 zeros, and 2 of them it looks like are right on the line at x equals 1, and then we've got a few fractions there. So let's see, what am I supposed to do? Approximate any real zeros. So there we go. So if I tap on this point, I get 1.68. And this one, is that going to be right on? No, it's at 0.421. And then is it symmetric? Negative 0.421. And negative 1.68. And relative extrema. Okay, so an extrema, that would be maxes and mins. So let's go ahead and we can visually inspect, and we have a maximum right here, and that is at 0, 1. And then these two minima, I've got one at 1.225, negative 3.5, and let me turn that off. And there I've got negative 1.225. So this makes me feel like asking you if this is an even or an odd function, and you should be able to see, since it's symmetric about the axis, it is going to be an even function. So number 61, we've got a new function with a 5th power. We've got x to the 5th plus 3x cubed minus x plus 6, and so I need to graph that. So x to the 5th, no, that's a subscript. X raised to the 5th plus 3x cubed minus x plus 6. Okay, so we've only got one 0 here, and that's at negative 1.178, 0. And I've got a max here at negative 0.324, 6.218. I've got a min right here, and it is symmetric. It's just raised up a little bit, so this wouldn't be an odd function. But since it doesn't cross any more places, I know there's some imaginary solutions to this problem. Sorry, let me fix this. And you can't see the graph either. So sorry. Alright, so that's what I ended up with for my graph. And those are the solutions. In number 65, I'm given 2 zeros. So if I'm given a 0 of 4, the key to this is to understanding that if I have 0 as if 0 is a 0, then part of my factored form is that I have an x outside the parentheses. And if 4 is a 0, then x minus 4 is a factor. So I can find my polynomial by simply distributing that. In number 73, we've got some more complicated zeros. We've got 2, 4 plus square root 5, and 4 minus square root 5. So, alright, that's not a factor, that's a 0. So I need to turn these into factors, which is a little bit trickier. So I've got x minus 2, and then I've got x minus 4 plus root 5, and x minus 4 minus root 5. So what I want to do in order to find my polynomial is go ahead and distribute these negative signs right here, and then I'm going to FOIL these out, and then I'll multiply whatever I get times this one. So this is going to be x minus 4 minus root 5 times x minus 4 plus root 5. And so I like to, whenever I have a 3 by 3, I like to use the box method to factor that out, and that way I don't miss a factor. And so I'll end up with 9 terms, and some of them will combine. Get x squared minus 4x minus x root 5 minus 4x plus 16 plus 4 root 5. X root 5 minus 4 root 5, and negative, so that's negative. Root 5 times root 5 is just 5. So I've got some things that are going to cancel and some things that are going to combine here. So x squared minus 4x and minus 4x is minus 8x. Positive x root 5 and negative x root 5 cancel. Negative and positive 4 root 5 cancel. And then I've got a 16 and a 5 here, so that's 11. So now I end up with a perfectly respectable quadratic trinomial. And I could go ahead and multiply that times x minus 2, which I'm also going to use the box method for that one. I just love how organized it is. X squared minus 8x plus 11, x minus 2, x cubed minus 8x squared plus 11x, minus 2x squared plus 16x, and minus 22. So that is going to give me x cubed minus 10x squared plus 27x minus 22 is my final answer. This is the polynomial that has these 3 things as zeros. So I am out of time. So numbers 79 and 85, please attempt those on your own, and we can discuss in class if needed.